and requires a retube, it's going to cost, in some cases, several $100,000 or $1 million. Your typical scale, common scale, is going to be the hardness in the water that's feeding the boiler system. That's the most common type of scale. So where is that hardness coming from? Well, it's coming from the city water or the groundwater or whatever your water source is to the makeup tank, whether it be a feed tank or a deaerator. Where's that water coming from and how clean is it? Those minerals get into the boiler, and as the steam leaves, I like to think of it this way: distilled water is steam that's been condensed. So as the steam leaves, it's not carrying anything with it, because we know that distilled water is really pure. So steam doesn't carry any minerals, right? So the minerals stayed behind in the boiler. So the boiler water is really thick with all of these dissolved minerals. So again, most of that being like calcium or magnesium, depending where you live, but generally those are the big ones. So as the boiler has more and more of these minerals in there, and the steam leaves and the junk stays, and the steam leaves and the junk stays, we're watching the number of cycles, or how much we're concentrating the junk in that water, by tracking boiler water conductivity. Typically is what we're going to do for that. So we're tracking boiler water conductivity to limit the concentration and how thick the water is with all of those minerals, if I can use that word, thick. And so if that gets out of control, or our softener quits working, then now the conductivity that we were measuring was cleaner water. Now it's got calcium in it that's conductive, rather than the salt that was in there before. And so where we're normally good to run at a conductivity of, say, 4,000, now 4,000 that's calcium instead of the salt off the softener is a significantly higher level of calcium in the water than it can hold. We're going to start to plate out that calcium onto the boiler tubes. And as we build that calcium onto the boiler tubes, what it's doing is really insulating those tubes. Okay, so typically a boiler tube is going to be very efficiently cooled by the boiling water. Somewhere in the neighborhood of 10 to 20 degrees hotter than the boiling water. So if our water is boiling at a temperature of 350, that boiler tube is going to be somewhere around 360, 370, 375 degrees. But now if I coat that tube with calcium, I'm reducing the ability of that boiling water to cool the tube directly. I'm sort of insulating the tube from its cooling source. So the tube temperatures go up and up and up. Well, as my temperatures go up, imagine that I have a tube rolled into two tube sheets, right? The shell and the tube sheets are all heated by that 350 degree water. But as I insulate that tube so that the water can't cool it, the tube gets hotter and hotter and hotter, and it begins to push out on those tube sheets until eventually it's either going to crack the tube sheet or it's going to pop those tube rolls loose, okay? So the effect of boiler scale is your boiler's going to run hotter. The tubes are going to run hotter. And what that means is your boiler's going to have these differential stresses, because the parts that are heated by the water are going to be significantly cooled than the parts that are heated by the flame and cooled by the water, or heated by the hot combustion gases and cooled by the water. And so you get all these differential thermal stresses in your boiler, and it begins to tear itself apart. So especially on a fire tube where those tubes are locked in on both ends, I don't have to build very much scale for those tube temperatures to begin to creep up and pop those tubes loose. Let alone the fact that because I'm cooling the tube less efficiency and the tube is running hotter, I'm removing less of the heat of the combustion gases, right? So the heat that I paid for at the natural gas meter, less of that heat is being absorbed into the water and making steam. More of that heat is going out the stack of the boiler. So as more and more of the heat goes out the stack of the boiler, my thermal efficiency goes down. So it is reducing my efficiency, but I tell most people the reason to prevent boiler scale is not the efficiency. The cost of the retube that you will need will far exceed the cost of the natural gas. So it's a huge reliability play, because when that critical boiler goes offline and requires a retube, it's going to cost, in some cases, several $100,000 or $1 million, depending on the size of the boiler. But on top of that, it's going to be downtime for that critical facility. So it's going to mean a rental or something of that nature, so that you can get that boiler offline to retube it or descale it. That'll be a talk for another day.